Okay, so now let's talk about the code for experiment 2. So pretty much the setup GPIO and the previous mentioned defines and um, pointers here and functions here, they're the same, and so is the setup GPIO. They're pretty much the same. The only difference with it's the same thing as experiment 1. The only difference is that the in this case for this experiment, right, our pointer stepper. So for experiment 2, our pointer stepper, instead of it being 0, is going to be, instead of it being 8, right, it's going to be C. So now why is it C, right? Okay, so if we look at our chart, right, we see that we see here, right, that essentially for a full step 2 phases at a time, right, for this chart here, with this with the one with the strongest torque. So pretty much we, for the step value for 1, right, it's 1 1 0 0, and if we convert that to hexadecimal, it gives us 0x0c, right? So that's where we get that number from, and that's why we have it here. Okay, so then now, right, we this number here is again the steps for 120 degrees divided by 5, right? And how did we get that? Just real quick again, just a quick recap of how we got that. So we have a motor, right? That essentially the um, we want it to turn 120 degrees, and we know the gear ratio is 64 to 1, right? So for a full step, we know that one 360-degree turn, it takes 32 steps. So if we do the desired angle over the 360 degrees that it turns times the turn gear ratio, it gives us this number, right? And then from that number, um, we could essentially uh, find our steps, right? Because now that we have our number of turns, which is 21.33 turns, we just multiply it times the number of steps it takes. So again, as I previously mentioned, it takes one 360-degree turn. It takes 32 steps. So using that ratio, and I get 682.56. And then again, we divide it by 5 because, as you can see here, our S is 5, right? So we have to divide that by 5. And yeah, so that's how we get the same number as in experiment 1. So that's that. And again, this for loop is for clockwise, and then this other for loop is for counterclockwise, and it has a delay of 500 milliseconds in between both. Okay, so now let's look at the code for experiment 2. So for experiment 2, right, we essentially wanted to do at 2 phases at a time. So in order to do that, we created a state machine, right? So this state machine is how we coded it, right? So we have different states here, right? We have different states here that I defined, and then we have this array, which um, it's the array values of the full step, right? And we pretty much get these numbers here from that table that I showed of how to get 0 of C in hexadecimal, right? And yeah, so now let's get into the code that we had to interpret using the pseudocode. So pretty much here, right, as you can see, we've created 2 variables, an int I variable, right, so our integer I variable, and we created a static states variable, which basically calls back to this. It calls back to this, to our structure. Yeah. And then we have some switch statements, right? Some switch case statements, which basically says case 1, right? So we start off with case 1, and it's going to go into case 1. So if the direction is clockwise, then the state is going to go on to the second state, right? Which is this one. And if it's not going in clockwise, right? If it's not going in a clockwise direction, then that means it's going counterclockwise. So it's going to go to the step before, which is step 4, right? And it's going to set the stepper to that number. And then it basically continues on the same thing with the same pattern, right? So for case 2, right, if the direction is going clockwise, then it's going to go on to the next one. If it goes counterclockwise, then it's going to go on to the previous one, right? So the previous case was 1, so it's going to go on to 1. And the next one, if it's going clockwise, right, it's going to go on to 3. And yeah, it pretty much repeats the same thing, as you can see here, right, for case 3, right, if it's going in a clockwise direction, it's going to go on to the next state. If not, it's going to go to the previous state, and same thing with case 4 here. And yeah, and then at the end we have a delay of 10 milliseconds. Okay, so yeah, let's now go see the results for this this part of the experiment. So yeah, let's go to it. Okay, so in this part of the video, I will show the results for experiment 2, lab 6, right? So pretty much in this experiment, it's similar to experiment 1. We want to rotate, we want this motor to rotate 120 degrees, right? We want it to rotate 120 degrees between, we just want it to rotate 120 degrees clockwise and counterclockwise, in a clockwise and counterclockwise motion. So, yeah, and as we can see here, it's rotating in a clockwise, right? So, it's rotating in a counterclockwise right now, and then once it rotates in this direction, it's rotating in a clockwise motion. So, this way, counterclockwise, so clockwise. And basically, what I did, right, to verify that it was correct, on these 2 post-it notes here, I used a ruler and a protractor to essentially pretty much measure out this angle here, so that it could look, so that we could verify that it's 120 degrees. And yeah, it was 120 degrees. So if we see, right, it hits this point here, rotates in a clockwise motion to here, that's 120 degrees, and then rotates back in a counterclockwise motion. So yeah, and then this one for experiment 2, this one is the one that has the highest torque. It's the one that has the highest torque, and it has this is the two phases at a time, and it's still a full step.